Good morning. Welcome again with our course Energy Engineering or Power Plant Engineering. Last lecture was 1.8 or 8 and lecture number 2 for this Energy Engineering. This video, we have seen this Rankine cycle with reheat, Rankine cycle with regeneration, and numericals on one on each of the type. So Rankine cycle plays an important role in this thermal power plant, you can say, because it is the basic cycle of this Rankine cycle. Various efforts have been made to modify to Rankine cycle and to improve the efficiency of the thermal power plant in all. So last time we have seen, in brief, I will again explain. This is the simple Rankine cycle with 1 to pumping, 2 to 3 heating in the boiler, 3 to 4 expansion, isentropic expansion in turbine, 4 to 1 condensation in the condenser, and 1 to 2 again pumping back to the boiler. So this simple Rankine cycle with the components boiler, turbine, condenser, and pump in thermal power plant. Then we saw the formulae used. Keep it in mind always, the suffixes wherever you take. Here you can take 1 here, 2 here, like that, or here 1, 2 as shown. So based on these suffixes, the formulas come like this: work pump, heat supplied, heat given out in the condenser, work done by the turbine, and other formulae just we saw. Okay, I'm going in just brief because I want to explain this Rankine cycle with some slides so that it will be again clear. You will get clear idea of. So particularly that cycle is a basic cycle which can be for various megawatt power plants. Then we saw numerical on the Rankine cycle. What are the things to be kept in mind while solving the numericals? I just told the suffixes are most important. Then I always try to draw this figure and the TS diagram so that it will be very easy to solve the problem. Then second step is to write down the given data after reading. Then after writing this given data, then below that or to the right side, you write the various values of enthalpies, H1, H2, H3, H4, H5. First write down those we get from the steam tables or those we are given in the example. Then after writing the values of H, various H, and now try to find out the remaining values, those we are not knowing, with the help of the data given. Then finally, you substitute the values of these enthalpies in various equations: efficiency, steam rate, then you can say heat supplied, heat rejected, work done by turbine, work done by pump, etc. That I explained. So in brief, again, I am telling this same thing with the reheat. In the reheat, the steam is expanded in 2 stages instead of 1. While expanding in second stage, the steam which is coming out of the first turbine is being reheated. That's why it is called as reheat. And again reheated to its original superheated temperature, and then again it is expanded in the lower turbine, LP turbine we can call, and then it is condensed. So what happens due to this doing the work in 2 stages, it automatically improves the work done and improves the efficiency. Second thing, the moisture content which was earlier higher side now gets reduced due to the reheating process. Okay, so this reheating process shown on this diagram, I'm again going to explain with the help of this slide. So I'm not taking more time on this numericals on reheat center regeneration cycle. In the regeneration cycle, you are be seeing the feed water incorporated between the 2 pumps, and so that the water before going to the boiler is being preheated in the feed water heater so that the efficiency can further be improved. Okay, so today and before that, one more thing I wanted to explain. So here I just told in the last where it was, sorry. So the moisture content, I have told dry, instead of dry, it is the moisture content in the is 12.76. It is not dry. So moisture is 12.76% and dry is 0.87. So the steam which is coming out into the condenser is 0.87 dry and 0.12 or 0.13 is way like that. So moisture is 13% present in the steam while coming it out. Just correct it. Okay. So now we'll go directly to the slides by which you can get the clear idea of the this reheat, regeneration, and simple Rankine cycle. Again, I am telling to keep it in mind while solving the problems on this reheat, regeneration, or simple cycle. You just draw the diagram, simple diagram like this, and also a line diagram of the boiler, turbine, generator, condenser, and then pump, so that it will be easier to solve the problems. So this is the regeneration cycle, which is shown. You can see here, I have explained it. Then 1 to 2 is the pumping, 2 to 3 is going in here in the boiler, 3 to 4 again is sorry, 2 to 3 is the heating in the LP heaters. 4 LP heaters are there, 1, 2, 3, 4. 3 to 4 pumping, boiler feed pump, again heating with the help of HP heaters, extraction 5 and 6. Then after heating, they goes to the boiler where it is again heated. So to the superheated. First stage 7 to 8 expansion in HP turbine, then reheated 8 to 9, then 9 to 10, you can say expansion in IPT, and further expansion 10 to 11 in LPT. So 3 stages are shown here in this. Okay, and in between that, HP heaters are also shown. Then finally it comes to the condenser at point 11, where it gets condensed to 1 as shown. So this is the blue zone is shown is the heat rejected, and the heat added is shown by this you can say 2 to 3, 4 to 5, and 5 to 7 in the boiler. Okay, thank you. Now we'll just see the animation or slide so that you can get clear idea about the Rankine cycle. See here, first of all, we'll see the simple cycle. Simple Rankine cycle. As seen, this is the work done by the pump, W2, and then this red line is shown in the heated up to superheated steam in boiler, that is the heat supplied Q1, and work done in the turbine by means of isentropic expansion, this blue line, and then it comes to the condenser. So it is a, you can say, partly moisture inside this, and then it is condensed in the condenser, that is yellow line, and heat is rejected in the condenser. Okay, so this is the we have seen in the simple Rankine cycle. Then we'll see reheat cycle with the help of slide again. So you're seeing the 2 turbines instead of 1. So we start with this superheated steam coming from the HP turbine, coming from the boiler to the HP turbine. It's expanded in the turbine. He's shown heat energy converted into mechanical energy, and then exhaust steam, instead of going to condenser, goes to the reheater zone in the boiler, again gets reheated to its original temperature, superheated temperature, and with less pressure. Then it goes to the, that's why it is called as a low pressure turbine, but temperature remains almost same. Again here gets expanded. So what happens due to reheat? The part of the steam or the part of the heat which is remaining with the steam, and addition of again heat in the boiler. So that heat plus remaining heat again gets expanded in the low pressure turbine, and then maximum extraction of the heat converted into mechanical energy by means of rotation of the shaft here, which converts this generator converts mechanical energy into electrical energy and sent to grid. Then exhaust steam coming to the condenser where it gets condensed, and with the help of this cooling water circuit, we have seen the circuit, cooling water circuit, cooling water pump is there. Cold water goes into the condenser tubes, and hot water goes to the cooling tower. By means of natural draft or artificial draft or forced draft, the heat is being thrown out to the atmosphere, and the cold water is recirculated again in the condenser, whereas the steam which is in the shell, it gets cooled, and that cooled, we call it as condensate, flows through the condenser extraction pump to the economizer, to the evaporator, reheater, and superheater. In this is the boiler zone. Okay, so in this way, then we see the reheat cycle work done by the pump. 1 to 2 here we can say, 2 to 3 you can say directly superheated in the boiler, okay, furnace. Then 3 to 4 you can say blue line expansion in HP turbine, then reheated again in the boiler in the reheater zone. 4 to 5 you can say red line. Then 5 to 6 is the expansion taking place in the low pressure turbine, and then at point this it is condensed, the yellow line shown, to the fully water. That's why it is shown on the water line. So heat is rejected, Q2, heat is supplied, Q1. Work is done in two parts, in HP turbine and IP turbine. Heat is added in boiler 2 times, this red line shown. So this is the reheat cycle. Okay, now we'll see the regeneration cycle. In regeneration cycle, there is a feed water instead of turbine. You can see, so superheated steam comes to the turbine, and when it is going to the condenser, part of the steam is being extracted in one of the stages and taken to the deaerator, or you can say feed water heaters, and then this exhaust steam comes to, part of the steam comes exhausted to condenser, where again it is cooled with the help of cooling circuit, and this cold water or condensate is being sent to the feed water. Here it is written deaerator. Deaerator is also one part of type of heat exchanger, wherein the water is being heated and then pumped with the high pressure pump, BFP, boiler feed pump, to the boiler furnace, where again it gets superheated and the cycle continues. In this regeneration cycle, you are seeing this deaerator or feed open water, you can open feed water heater here. So the what are the processes taking place on TS diagram? 1 to 2 pumping, 2 to 3 you are seeing okay, going through after pump, it is going to the economizer, then it is again from CEP, it is from CEP, it is shown green line, then it is going to deaerator feed water where it is heated, then again after heating it goes, it is pumped by BFP, then it is taken to the boiler where it is heated up to red line, superheated, that we can call it as up to 0.3 you can say, then it is expanded in the turbine, that work output is there W1, and then it is condensed in the condenser, that is yellow line, heat is discharged, that is Q2 in the cooling tower, and Q1 is the heat supplied with the help of coal coming from the coal handling plant, and the flue gases are going to the atmosphere. Okay, so this is in brief about the regeneration cycle. Now if you see the combination of the reheat and regeneration, little complicated. There are 2 turbines now, again instead of 1. Reheating takes place in this by yellow line, and this when it is going, part of the steam extracted from HP turbine and LP turbine to the deaerator or feed heaters, number of feed heaters. In our plant, there were total 4 low pressure heaters and 3 high pressure heaters, and plus 1 deaerator. So total 8 extractions were there. So through this 7 extraction, 8 extractions, and through these extractions, part of the steam is going for heating. Okay, so this reheating plus regeneration is taking place. Again, there is condenser, cooling circuit, pumping, low pressure heaters, and then it related to then BFP, and it is going to the boiler zone for generation of steam. So this is the combination of reheat, 2 stages, and regeneration, feed water heating in the deaerator and feed water heaters. So it is shown here again, pumping action here, feed water heating, then again boiler feed pump and goes to boiler heating. Q1 heat is the supplied, then HP turbine expansion, again reheating in the reheater, expansion in low pressure turbine. Work done is equal to W1 plus W H high pressure plus W low pressure. It will be W1. Then it is coming to condenser where it get condensed. The heat is discharged to the atmosphere in the cooling tower, that is Q2. So in this way, combination of reheat and regeneration cycle also takes place. Okay, I hope. So now, what are the points to be remembered while solving the numericals? The numericals are very simple. Just you have to take the help of this Rankine cycles. I will explain with a reheat and regeneration cycles in brief again within 1 minute. You can say in this in reheat cycle, you can, if you write down 1, 2, 3, 4, 5, 6, 7, 8 like that. So H1 to H2, H8 you have to write to the right side. And if the data is given, these are the yellow line is the pressure, second pressure, low pressure line. This red line is high pressure line. This point where you can just draw the one line, dotted line, this will be the intermediate pressure line or reheated pressure line. So if you draw this, if you know this TS diagram very well, so you can solve any type of problems on reheat as well as regeneration. Okay. Okay, if any problem comes, again if time permits, we'll solve few more problems on this reheat and regeneration so that it will be clear to you. I hope you understood. Thank you. Thank you very much.